Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 10, Interpreting Graphs of Proportional Relationships. Classwork Example 1. Grandma's special chocolate chip cookie recipe, which makes 4 dozen cookies, calls for 3 cups of flour. Using the information, complete the chart. Now, the only problem with this is the words calls for. We usually say 4 dozen cookies to 3 cups of flour, or 3 cups of flour to 4 dozen cookies to determine a ratio. And in this case, I don't know if it's 4 to 3 or if it's 3 to 4. Which is it? That's the question. So I need to bring in some more terminology here. So this says to create a table comparing the amount of flour used to the amount of cookies. So there it is, flour to cookies. So if I do a T-chart and I go like so, before we already knew that there was an X and a Y. Okay? But now I want to bring in more terminology. And X is independent. It is the independent variable. And Y is the dependent variable. Okay? So, if we talk about children and parents or guardians, the parent or guardian is independent. They have their own home. They have a job usually that buys the food and the clothes and pays for the home and all that kind of stuff. And kids go to school. They don't have a job that gives them money, that gives them an opportunity to feed themselves, clothe themselves. So they depend on their parents or guardians to meet their needs. So if you think of it that way, kids are dependent, parents and guardians are independent. So what your parents say will determine what you do. So if your parents say go to bed, then you are going to go to bed, and that is going to be a result. So they have an influence on you, if you will. And the same goes with these variables. X influences Y. So in this situation, if I didn't have this sentence here and they only gave me this up here, then I'd say, well, if the number of cookies I make depends on how much flour I have, or does how much flour I have depend on how many cookies I made? It doesn't. So if I made a batch of cookies, that doesn't mean that's all the flour I had. I could still have flour left in the cupboard. But if I'm going to make cookies and I only have so much flour, then I can only make so many cookies. So the amount of cookies is dependent on the amount of flour. So the cookies dependent would be, and I'll do this in blue, this would be dozens of cookies. D-O-V, how about D-O-Z? Dozen of cookies. Dozens of cookies. And over here is cups of flour. And we're told that we have 3 cups of flour to 4 dozen cookies. Flour to cookies. Okay? So the more flour I have, the more cookies I can make. The less flour I have, the less cookies I can make. So that makes sense. So the number of cookies we make depends on the flour we have. All right, so now we're going to do repeated addition, which is the same as multiplication, and we're going to finish a table. 3, 6, 9, 12, 15, and 4 and 4 is 8, and 4 is 12, plus 4 is 16, plus 4 is 20. So I have these sets of numbers. Then it asks, is the number of cookies proportional to the amount of flour used? Explain why or why not. Well, if I take 4 divided by 3, that doesn't reduce. So I'm doing y over x here because that's what k is. K equals y divided by x. We're looking for our constant of proportionality to see if this is proportional. So 4 over 3, 8 over 6 reduces to 4 over 3, 12 over 9, 12 divided by 3 is 4, 9 divided by 3 is 3, 16 over 12, 16 divided by 4 is 4, 12 divided by 4 is 3, I wrote 4 again, 6 16 divided by 12 equals 4 over 3. And then finally, 20 divided by 15. If I divide 20 by 5, I get 4. If I divide 15 by 5, I get 3. So we're getting 4 thirds, 4 thirds, 4 thirds, 4 thirds. So I would say yes. And because the constant of proportionality y divided by x is 4 over 3. Okay, we have a constant of proportionality, so therefore it is proportional. What is the unit rate of cookies to flour? For example, y over x. Well, we've already done that. It's right here. Y over x reduced to the greatest. So, what is the unit rate of cookies to flour? Unit rate of cookies to flour is 4 over 3. And what is the meaning in the context of this problem? Which means, I'll do comma, which means for every cup of flour, we can make 4/3 dozen cookies. Okay, or 1 1/3. So 4/3 equals 1 1/3. Well, we know a dozen is 12, and a third of 12 is 4, so that'd be 12 plus 4, or 16 cookies. It didn't ask that, but you need to be able to explain yourself in different ways. Okay, so that's 16 cookies. So 1 cup of flour will make 16 cookies. That's kind of neat. Okay, so now it says model the relationship on a graph. So the first thing we need to do is we have these axes. I'm not going to draw them because it's hard to draw a straight line without getting my ruler out. But let's put an arrow here and an arrow here to show that they're going on forever and ever and ever. And that is the points, that is the origin 0, 0. First things first. Okay, the x-axis, which is here, and I'm not going to call it x. I am going to say cups of flour f and dozens of cookies c instead of x and y. So we're going to use f and c. So x is my x-axis, which is down here, and I'm going to call that f instead. And this is my y-axis, but we're going to call it our c-axis in context of this problem. This is what we're starting to lead into. In the context of this problem, what would x and y be? F and c. And now I'm going to plot these points. But before I do that, we should always label what our axes mean. So I should have down here cups of flour. And over here, dozens of cookies. Okay? And now I'm going to plot these. So this, and then I have to have a unit of measurement here. My biggest number in my x-axis is 15, and if I count across here, there are 15 squares. I'm just going to label every 5, 10, and 15 instead of all of them. It's too cluttered if you do that. And I'm going to do the same up the side. 1, 2, 3, 4, 5 would be right here. 6, 7, 8, 9, 10 would be right here. 11, 12, 13, 14, 15 is here. And 16, 17, 18, 19, 20 is right here. That is dozens of cookies. So I'm going to plot the points now, 3, 4, which means go to the right 3 on the x-axis and up to 4 on the y. Put a dot there and label it 3, 4. Go over to 6 and up to 8. And label it 6, 8. And then we're doing 9, 12. Go over to 9, up to 10, and 2 more is 12, and that's 9, 12. Go over to 12, go up to 16, right here, and that is the point 12, comma, 16. And finally 15, go up to 20, and it's right here, 15, comma, 20. So we have all these points here, and I'm going to put a dot there, and I'll explain that in a moment. So here they are. They look like they're on a nice straight line. They appear to be on a straight line. So it says, does the graph show the two lines being proportional to each other? So I would say yes. The points appear to be on a straight line, and they include the origin 0, 0. Okay, decided to clean that one up, and I should probably do this one too, so I probably will. And then it says, write an equation that can be used to represent the relationship. Now we're going to start talking about the equations. Okay, so I'm first going to write y equals kx. That's our equation we're going to use, y equals k times x. Y is the dependent variable, and in this case, I'm going to rename these. Y we're going to replace with c. So it's going to be c equals. Our constant of proportionality is y over x. We've already found it. It's right here. It's 4/3. Okay, so I'm not going to do the math again. We've already done it. 4/3. And x is our independent variable, and that's our cups of flour, so I'm going to say f. So c equals 4/3 f. There's an equation that can be used to represent our relationship. So if I have 1 cup of flour, I'll make 4/3 dozen cookies. 2 cups of flour, 8/3 or 2 2/3 cups of, or dozen cookies, and so forth. Okay, so there we have it. And let me, okay, so there I cleaned that up a little bit. Unit rate of cookies to flour is 4/3, which means for every 1 cup of flour, we can make 4/3 dozen cookies. Okay, so there's our setup of that problem. Recapping, we made a chart, a table. Then we answered if it's proportional or not. Then we found the unit rate, which is the constant of proportionality. Then we graphed it, labeling our axis. And then finally, they look proportional graphically, and the reason. And then the equation that would create that line is c equals 4/3 f. Okay, example 2. Below is a graph modeling the amount of sugar required to make Grandma's special chocolate chip cookies. Record the coordinates from the graph. What do these ordered pairs represent? So the first one is 0, 0, which means 4, which means, let me try that again. If we have 0 cups of sugar, we can make 0 dozen cookies. That's what that means. Okay, so there it is, 0, 0, which means if we have 0 cups of sugar, we can make 0 dozen cookies. I'm only going to pick one more for this. It says several, but I'll just do 2. I'm going to pick this point right here, just randomly, and this is the point 12. And if I slide over here, it's right here, 15, 16, 17, 18. So this is the point, x is 12, comma, y is 18. And so I'm going to say what that means here. And there you have it, 12, comma, 18, which means if we have 12 cups of sugar, we can make 18 dozen cookies. Okay, B. Grandma has 1 remaining cup of sugar. How many dozen cookies can she make? So I'm going to plot this point on the graph above, which it says to do. So 1 is right here, So if I go up and put a dot on this line right here at 1, I'm in between somewhere here. So it's not 1, it's not 2, but it's somewhere in between. So this is the point 1 comma something, and we're working our way towards our unit rate now, R. And what that is basically is your constant of proportionality. So R is the same as K, which is the same as Y over X, which is 18 over 12 in this case. And if I reduce, half of 18 is 9, half of 12 is 6. 9 will be divisible by 3. 3 times 6 divided by 3 is 2. So there is my constant of proportionality. So when I get to 1 and I go up here, I'm at 3 halves, or 1 1/2. Okay, so if she has 1 cup of sugar, she can make 1 1/2 dozen cookies. With 1 cup of flour. Okay, so there we go. She can make 3 halves, or 1 1/2 dozen cookies with 1 cup of flour. C says, how many dozen cookies can Grandma make if she has no sugar? Well, if you have no sugar, you have no cookies. So she can't make any cookies if she has no sugar. Okay, so there that is. She can't make any cookies if she has no sugar. How can you have any cookies if you don't have any sugar? All right, so can you graph this on the coordinate plane provided above? Yes, it's right here. 0 cookies, 0 sugar, or 0 sugar, 0 cookies. So let me show you that. Sugar, 0, cookies, 0, the point 0, 0. And it says, what do we call this point? And this point is 0, 0. We call this point the origin, where the graph originates. Okay, moving on to exercise 1. The graph below shows the amount of time a person can shower with a certain amount of water. Can you determine by looking at the graph whether the length of the shower is proportional to the number of gallons of water, and explain how you know? Well, the first thing I would do is look here, and I have 0, 0. I have 0, 0. Check. Okay, and then I'm going to pick a point. How about this one here? That is 25, 30, 35, 40. So this is 30, and this is 10. So if I take, so this is the point 10 comma 30, which is 30 divided by 10, my y over x, which equals 3 over 1, which is 3. And then if I pick this point here, that's 50, comma 15. So then I need to do 50 divided by 15. And 15, is that right? 40, 50, 15, yes. 15 goes into 45 3 times the remainder of 5, and that's going to be 3.3 repeating. Okay? And then if I go here, that's 60, 20, which is 6, whoops, let's do this way, 60, comma, 20. Okay, I made a mistake here. Let me fix this. My apologies. This is the point 30, comma 10, and it's y divided by x. I can't believe I did that. 10 divided by 30, which is 1/3, which means 0.3 repeating. Okay, and let me do this one again. This is 15 divided by 50. And 5 will go into 15 3 times, 5 will go into 50 10 times, so that equals 0.3, but it's not repeating. And this is 60, 20, so 60 is y divided by x, which is 2 over 6, which reduces to 1 over 3. And then this point is 5, 10, 15, 20. This is 15, comma 5. So if I do 15 or 5y divided by x, then that's going to be 1 over 3, which is 0.3 repeating as well. But this 50, 15 doesn't seem to be working right. Okay? And now when I look at this, if this is 40 and this is 60, there's 5, 10, 15, 20 to get 60. They're 5 apiece. This is not 50, 15. This is 45, 15. So I'm going to fix that. And this is going to be 45 here. So let me just put a 4, 5 there and get rid of that. And now 45 divided by 15 is going to reduce to 1 over 3. Okay, so it's 1/3, 1/3, 1/3, 1/3. And therefore, by looking at the graph, it is proportional because it goes through the origin and the points are all on a straight line. I checked it algebraically, and we do have a constant of proportionality or rate. B says, how long can a person shower with 15 gallons of water? So gallons is down here. Here's 15. And so 15 gallons of water will give me, so the person can shower for 5, and they labeled this nicely, minutes. Okay? How long can a person shower with 60 gallons of water? 60 gallons is here. The y is 20 minutes with 60 gallons of water. C, what are the coordinates of point A? So I come back up here. Point A is right here. It is 30, 10. So the A is 30, 10. Describe what that means in the context of the problem. So I'm going to type this in real quick. Okay, so there it is. A is 30, 10, right here. A, 30, 10. Means that if you have 30 gallons of water, then you can shower for 10 minutes. Can you use the graph to identify the unit rate? And the answer is, of course, yes. The unit rate is 1 comma something. So I need to know what y is when x is 1. So if I come over here and this is 5, this is 1, and I put a dot there, it's really hard to do just by that, but I can use my unit rate here. That's my rate, 1/3. If I went over 1, I'm going up 1/3. So I would say yes, 1 comma 1/3 would be my point. And that means, I'm not going to write it, but it's right up here. That means that if I had 1 gallon of water, I can shower for 1/3 of a minute. And 1/3 of 60 is 20 seconds. So 1 gallon of water, a 20-second shower. So we are going to call that point 1 comma R for rate. And our rate is 1/3, which is our constant of proportionality. E says to write the equation to represent the relationship between the number of gallons of water used and the length of the shower. So we use the equation y equals kx, but in our situation, x is g and y is m, gallons, minutes. X is g, and y is m for minutes, and k is 1/3. So my equation is m, the number of minutes you can shower, is equivalent to 1/3 times the number of gallons you have. Two, your friend uses the equation C equals 50p to find the total cost C for the number of people entering a local amusement park. Create a table and record the cost of the entering amusement park for several different size groups of people. So I'm going to create a table, and I want an XY table, so I'm going to just do my table like this, and I'm going to do XY. but then I'm going to erase my x, and I'm going to call that independent, and I'm going to erase my y, and I'm going to call that dependent. I'm just going through this to solidify this understanding. This is dependent. Okay, so finding the cost, C, people entering. So the more the people come, the more money it's going to cost. So the cost is going to be dependent on how many go. And now I finally determined that my cost is my dependent variable, and my number of people that come is independent. So the more people come, the more the cost is. So people is independent. I'm going to create a table of records that shows the cost to the amusement park in different size groups. So let's start with 1. If I have 1 person, it's going to cost $50. If I have a group of 2, it's going to cost $100. If I have a group of 3, it's going to cost $150, and a group of 4 is going to be $200, and I can go on and on and on by just simply adding 1 to the left and adding 50 to the right. Okay. B says it costs. Is the cost of admission a proportional to the amount of people entering the amusement park? Explain why or why not. 50 divided by 1 equals 50. 100 divided by 2 equals 50. 150 divided by 3 is 150. 200 divided by 4 is 50. 250 divided by 5 is 50. And 300 divided by 6 is 50. So the cost is proportional. Yes, because how do I want to word this? I'm just trying to think. Because our rate is $50 per person, and it never changes. Okay? That's all I'm going to say there. C, what is the unit rate? Okay? The unit rate is $50. What does it mean in the context of this situation? For every person entering the park, it costs $50. Okay, so there we go. The unit rate is $50, which means for every person entering the park, it will cost $50. One person, $50. D says sketch a graph to represent this relationship. So I'm going to go back, look at my table, and P is my X, C is my Y, P is my independent variable, C is my dependent variable. Okay, so on the bottom here, I'm going to put number of people. Didn't give me a lot of room here to write. Number of people, and up the side it's going to be total cost to enter the park. I'm going to label this point 0, and I'm going to label this, let's just spread this out, 1, 2, 3, 4, and this will be 50, 100, 150, 200. And if I go back to my table, 150 to 100 are the first 2 points. So then when I graph this, I go over 1, I go up to 50, 2, 100, 3, 150, and 4, 200. So that's what my graph would look like. What point must be on the graph of the line if the two quantities represented proportional to each other? And the answer to that is the origin 0, 0. Explain why and describe these points in the context of the problem. Okay. Okay, so it says 0, 0, and 1, comma 50. So we pick 2 points here, this one here, and 1, comma 50 is right here. Right here, 1, comma 50. So if 0 people enter the park, then the cost will be $0. And if 1 person enters the park, the cost will be $50. For every 1 unit increase along the horizontal axis, the change in the vertical distance is 50 units. So if I go over 1, I'm going up 50 more. Go over 1, going up 50. Go over 1, going up 50. Okay? F. Would the point 5, comma 250 be on the graph? And what does this point represent in the context of the situation? So if I came out to 5 and put a dot at 250 somewhere over here, somewhere around here, over here somewhere, then would it be on the graph and would it be on the line? And what is the context of 5, 250? Okay, so yes, the point 5, 250 would be on the graph because 5 times 50 is 250. Meaning, the meaning is that it would cost a total of $250 for 5 people to enter the amusement park. Okay, read this lesson summary. That is the end of lesson 10. Go do your problem set.